Good morning, students. Today we will start the new chapter of the physical chemistry known as surface chemistry. Surface chemistry is that branch of the chemistry which generally deals with the study of the phenomena which are occurring at the surface or the interface. What is the interface? That is, at the boundary separating the two bulk phases. The two bulk phases can be pure compound or a solution. The interface is represented by putting a hyphen or a slash between the two bulk phases involved, that is, solid dash liquid or solid slash liquid. No interfaces are exist between the gases because they are completely miscible with each other. It is an important branch of the chemistry because the various number of phenomena are occurring at the surface or interface. These are dissolution, crystallization, corrosion, heterogeneous catalysis, electrode processes, etc. Now, in this unit, we have to study about the various topics in surface chemistry. First is adsorption, absorption, catalysis, and colloids, including emulsions and gel. We have to study in this unit. Now, what do you mean by the adsorption? The phenomena of attracting and retaining the molecule of the substance on the surface of the liquid or a solid, resulting into the higher concentration of the molecule on the surface is called adsorption. The substance thus adsorbed on the surface is called the adsorbate, and the substance on which it is adsorbed is called adsorbent. The reverse process, that is, the removal of the adsorbed substance from the surface, is called desorption, which can be brought about either by heating the surface or by reducing the pressure. The adsorption of the gas on the surface of the metal is known as occlusion. Now, here in adsorption, the accumulation of the molecular species at the surface is higher than in the bulk of the solid or liquid. The molecular species or the substance which will get concentrate or accumulate at the surface is known as adsorbate, and the material of the substance of which the adsorption takes place is called adsorbent. Action of adsorption. As we know that if a gas like O2, H2, chlorine, ammonia and sulfur dioxide is taken in the closed vessel containing the powdered charcoal, it is observed that the pressure of the gas in the enclosed vessel decreases. Why this pressure decreases? The pressure decreases because the gas molecule concentrate at the surface of the charcoal. That is, the gases are adsorbed at the surface. Now, in a solution of an organic dye, say the methylene blue, when the animal charcoal is added, the solution is well shaken. Then it is observed that the filtrate turns colorless. The molecule of the dye thus accumulate on the surface of the charcoal. They are adsorbed. The third example of the adsorption is accumulation of the raw sugar when passed over the beds of the animal charcoal become colorless as the coloring substance are adsorbed by the charcoal. The air become dry in the presence of the silica gel because the water molecules get adsorbed on the surface of the gel. The process of removing an adsorbed substance from the surface on which the adsorbed is called desorption. Now, what are the difference between adsorption and absorption? As we know that adsorption, it is a surface phenomena. It occurs only at the surface of the adsorbent, while absorption, it is a bulk phenomena. It occurs throughout the body of the material. Second, In adsorption, the concentration of the surface of adsorbent is different from that in the bulk. While in absorption, in this phenomena the concentration is same throughout the material. While in adsorption, its rate is high in the beginning and then decreases till the equilibrium is attained. While in absorption, its rate remains same throughout the process. So these are the basic differences between adsorption and absorption. Another examples are also here for adsorption and absorption. For example, the water vapors are absorbed by calcium chloride, but they are adsorbed by silica gel. The another one, both the adsorption and absorption can take place simultaneously. Then we use the process known as sorption. In sorption is the process in which adsorption and absorption both takes place simultaneously. Now what is the mechanism of adsorption? We know that the texture existing at the surface in the case of the liquid and solid is totally different from that of the interior. For example, a molecule in the interior of the liquid is completely surrounded by the other molecule from all the sides, and hence the intermolecular force of attraction is extremely equal in all the direction. The molecule at the surface of the liquid is surrounded by the large number of the molecule in the liquid phase and fewer molecule in the vapor phase. As a result, these molecules which are lying at the surface experiences some net inward force of attraction which cause the surface tension. This inward force of attraction existing at the surface of the solid, or alternatively we can say that the solids such as the transition metals like nickel, platinum, palladium, they are utilize their free valencies at their surface because of the unbalanced inward force of attraction or the free valencies at the surface. Solids and liquids have the property to attract and retain the molecule of the gas or a dissolved substance on their surface with which they come in contact. The forces of the adsorbent are responsible for attracting the adsorbate particles on its surface. The extent of adsorption increases with the increase of surface area per unit mass of the adsorbent at a given temperature and pressure. The another important factor, that is adsorption, is the heat of adsorption. During the adsorption, there is always a decrease in the residual force of the surface. That is, there is a decrease in the surface energy, which appear as a heat. In adsorption, therefore, is invariably an exothermic process. In other words, delta H of adsorption is always negative. When the gas is adsorbed, the freedom of the movement of its molecule become restricted. This amount to decrease in the entropy of the gas after adsorption, that is delta S is negative. Adsorption is thus accompanied by decrease in the enthalpy as well as decrease in the entropy of the system. For the process to be spontaneous, the thermodynamic requirement is that at constant temperature and pressure, delta G must be negative. There is a decrease in Gibbs free energy. On the basis of this equation, delta G is equal to delta H minus T delta S. Delta G can be negative if delta H has sufficiently high negative value, as T delta S negative is positive. Thus, in an adsorption process which is spontaneous, a combination of these two factors makes the delta G negative. As the adsorption proceeds, delta H becomes less and less negative. Ultimately, delta H becomes equal to T delta S and delta G becomes 0. At this stage, the equilibrium is attained.